We're going to take a second look at dividing monomials here. We already did this, but I want to make sure that we're completely clear about what's going to happen with dividing monomials as we continue going along here. The first one, the first few, I just want you to look at again in the long version. So x to the fifth, there's 5 x's on top. X to the second is like 2 x's on the bottom. If you can think about this without having to actually go through and write this portion, then that's the goal that you should have in mind. That when you look at this division problem, you should say, well, I've got 5 x's on top and 2 x's on the bottom. The 2 x's on the bottom are going to cancel with 2 of them on the top, which leaves me with 3 x's on the top. Please, if you need to write it out, then write it out. Don't waste all this extra space that I gave you if you don't know how to do it or don't know how to do the rule. Okay, you actually write it out. So again, this is 7 y's on top and 2 y's on the bottom. The 2 y's on the bottom are going to cancel with 2 y's on the top, and it's going to leave 5 y's up on top. Okay, so you should put them on top of the fraction. If you feel better about putting it on top of the fractions like this, so x to the third over 1, and then making the answer that, then fine, please do that. Which then continues with number 4, so I've got 3 x's on top and 6 x's on the bottom. The 3 x's on top are going to cancel with 3 x's on the bottom. But when they cancel, you need to remember that there's a lazy 1 in front, and so there's a 1 on top because nothing is left up there. Just like when there's nothing left in the denominator, there's a 1 in the denominator. We can be lazy about the denominator 1. We cannot be lazy about the 1 on top in the numerator. And there's still x cubed here for the finishing of that answer. Jump a little bit farther down. Let's say number 11. Again, the long version is still there. I'm going to stop using the long version because it becomes a lot to write, but I'm still using the long version in the language. So on top I've got an 8 and a 12, so I still want to reduce this like a fraction, so 4 goes into 8 twice and 4 goes into 12 3 times. So I end up with 2/3 as my numbers. I've got 5 a's on the bottom and 2 a's on top, which means that the 2 a's on top are going to cancel with 2 of them on the bottom to give me 8 to the third in the denominator. With the b's, I've got 7 b's on the bottom and 3 on top. So the 3 on top are going to cancel with 3 in the denominator and give us b to the fourth. C to the eighth and c to the third. I've got 8 c's on the bottom and 3 on top. The 3 on the top are going to cancel with 3 of them on the bottom. And I'm going to end up with an answer like this. Now you can take and you can center that too, or you can make it look a little bit prettier than what I have written. But ultimately that's what we're looking at. In number 14, I've got a 6 and a 36 on top, so 6 goes into 6 once and into 36 6 times. So I've got a 1 and a 6 with that negative still out front. I have 7 d's on top and 9 d's on the bottom, so the 7 d's on top are going to cancel with 7 of the 9 on the bottom and leave me with 2 d's left in the bottom. And I've still got that c to the fourth. There are no c's anywhere else to be found, so that's going to be it for this problem. Jumping to the back, dealing a little bit with some negative exponents. Number 19, I've got x to the third. That does not have a negative exponent. The x to the sixth does have a negative exponent, so I need to bring that from the bottom of the fraction to the top of the fraction, which now brings us to the rule of like bases. I've got 2 like bases. I want to go ahead and add the exponents together. So 6 plus 3, or again, if you're thinking in terms of I have x's, I have 3 x's, and I have 6 more x's. That means that I have 9 total x's. Jump down to 22. Number 22, I've got the numbers I want to deal with like a division problem. 5 goes into 5 once and into 24 times. So I have 4 on top and 1 on the bottom. I've got x to the negative third, so I need that x squared that's in the denominator already. X to the negative third needs to come down to the denominator, and y to the fifth is still stuck up on top. It doesn't have a negative exponent. So now I want to just rewrite that 4y to the fifth, and then I've got 2 x's and 3 more x's. That's x to the fifth. If you want to put the 1 in front, that's fine, but you don't have to, because you can be lazy about it. There are lots of things in math that you can be lazy about. Writing down steps is not one of them, but ones in places that they don't need to be is going to be one of them. If you want to attack that in a little bit different way, if the first thing you see is the negative exponent, then you should attack it that way. The negative exponent is on the b, and so I've got all of this on the denominator, plus I'm going to bring down that b to the negative 7th. So now the number is reduced. 4 goes into 4 once and into 8 2 times. So I end up with 2 over 1 for the numbers. I have 5 a's on the bottom and 2 a's on top. So the 2 a's on top are going to cancel with 2 of them on the bottom and leave me with 3 in the bottom. And then finally I've got 2 b's on the bottom, 7 more b's on the bottom. So I've actually got 9 b's in that denominator. Jump down to the very last ones. These are the most complicated ones we have. I've got a bunch of negative exponents, so that's the first thing that I'm going to take care of. Everything up to this point doesn't have any negative exponents, but I have negative exponents on the y to the third, so that's going to go to the bottom. A negative exponent on the y to the sixth, so that's going to go to the top. And a negative exponent on the z to the second, so that's going to go to the bottom. Now I can simplify. I have 4 over 14. 2 can go into both of those. So I end up with negative 2 on top and 7 in the denominator. The x's, there's 5 x's on top and 5 x's on the bottom. They're all going to cancel out with each other. It's like 2 divided by 2. X to the fifth divided by x to the fifth cancels out. On top, I've got 6 y's. On the bottom, I've got 3 y's. So those 3 on the bottom are going to cancel with 3 on the top. And then I've got z to the second power still in the denominator. There are no other z's anywhere else to cancel out or add to. Keeping in mind negative exponent rules, all of the adding and subtracting with exponents, keeping in mind all the dividing and the way that you want to think about these problems, this will end our exponent rules dealing with negatives and dividing.